Now we're going to continue to talk about double bipoles. Now, double bipoles can be expressed in two ways. They can be, well, as we said, they were actually, here we said that they have an implicit representation and an explicit representation. But today, I'm going to show you what I mean with a double bipole. Because, the definition is, you gotta know the definition, but it's a bit tricky. But it's all gonna be very, very, these one today you're actually gonna understand what a double bipole is. Now, double bipole can actually be expressed as T or as a capital Greek letter. Now, when they are as T, you can have the resistances, so the three resistors that are connected in a way that they actually form a T. So let me show you some examples of T. Now, if I have something like this, let's see. This and like this, and we have V1 here, V2 here. I call this A, this one B, C, this one O. This will be on my R1, RC, and well, I'm just gonna call this RA, RC, and RB. And the current flowing here as I2. Okay, now you can actually see that they're arranged as a T. Okay, so this is like a T. Now, the same goes for this representation. If I have a generator like this, and something like resistance, something here, and another resistance, and this one, this is another node, and this all the way down here, and all the way down here, and then you have, I don't know, like this V2, this one is V1, this is RA, RB, and then I have this one in the middle as RC. We still have the T. And the same goes for this third circuit here. With something like, yeah, running out of space here. Yeah. If I have something like this, and I'm going to define this as I1, and this I will define this as I2. And if I have RA, RB, RC, and I will have this one like V2, and this one will be my I2. All the way down here, we will still have the T. Now, in this case, we will have the R matrix. Remember that I talk about matrices. So yeah, linear algebra is gonna haunt you again. But it's fine because I like linear algebra. So R is gonna be given by RA plus RC, RC, RC. Oh shit, sorry. Sorry about that. And RC. So this is the matrix relative to this circuit. In this case, we have V1 equal to RA plus RC times I1, V2 equal to RC times I1. In this case, we have V1 equal RC I2, and V2 as RB plus RC I2. Now we can also have another configuration which is double bipoles expressed in this configuration. And if we have double bipoles expressed in that configuration, well, then we would basically have, well, I think you already figured it out, but I would have this, and I don't know, like I'm gonna call this A. I'm gonna have a resistance here. I'm gonna call this B, and something like this with, I don't know, some current I2. And then here I would have a resistance, and here another resistance, and down all the way down here we will have V2, V1, RA, RAB, and RBC. And I'm gonna call this A, B, and this whole thing here down C. And then you can actually see the big fat pi. Same goes for this other circuit. With these, which I'm going to define as I1. I don't know, this, the resistance, all the way to here, with I2 equal to 0, just like before. And then this, which is expressed as V2, and all the way down to this. This one will be then my V1, and then I will have a resistance here and another resistance here, and I will call this RAC, RAB, and RBC. And again, we have the big fat pi, and here again we'll have B1, resistance here in the middle, and current flowing through here, and the power supply, and something connected down here, and then resistance, and then another resistance, and this one will be my V1, and this one will be my V2. Then this is RAC, RAB, RBC, and again we have the big fat pi. Now on to the formula. We can actually find the matrix R as RAB, RAC plus RAC, RBC. And then here we would have over RAB plus RAC plus RBC. And here we will have RAC, well, this is not a minus, it's just something. RAC, RBC over RAB plus RAC plus RBC. Down, we would have RAC, RBC, everything over RAB plus RAC plus RBC. And then here, we would have RAB, RBC plus RAC, RBC over RAB plus RAC plus RBC. So this big fat guy will be our matrix. Then we will have V1 equal to I1 times RAC times RAB plus RBC. Everything over just this. RAC plus RAB plus RBC. And now V2 will be I1 times RAC over RAC plus RAB plus RBC times RBC. And lastly, let's see if I can squeeze it here. The V1 I2 times RBC over RAC plus RAB plus RBC, everything times RAC. Yeah, I'm really running out of space. And V2 will be I2 times RBC RAB plus RAC, everything over RBC plus RAC plus RAB. Okay. Now, a double bipole at T and a double bipole at pi can be the same if their matrices RT and RM are the same. So if RT and RM are the same, a double bipole at T can be the same as a double bipole at pi, which basically means that RT, so if RT, which is RA plus RC, if it's RA plus RC, RC, and RB plus RC is the same as RM, which is RAB, no, not a plus, RAB, RAC plus RAC, RBC over RAB plus RAC plus RBC. And here we have RAC, RBC over RAB plus RAC plus RBC over RAC, RBC over RAB plus RAC plus RBC. And here we have RAB, RBC plus RAC, RBC over RAB plus RAC plus RBC. So if those two guys are equal, then a double bipole at T can be the same as a double bipole at capital Pi. Now, if we look at the matrices, we can see that those relationship has to be verified. RA has to be RAB, RAC, RAB plus RAC plus RBC. RB has to be RAB, RBC, RAB plus RAC plus RBC. RC is RAC, RBC over RAB plus RAC plus RBC. And we can actually, those relationships, those three relationships, actually correspond to the formulas of transformation from a triangle to a star. So those are the formulas to go from a triangle to star, which is also called delta Y. Star and triangle and star, because the delta is basically a triangle and the star is a Y. So those are the formulas to go from a triangle to a star. A triangle is basically what you see. So three resistances, for instance, in a triangle will be three resistances like so, and a star will be instead like this. So in a very, 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 very simple way, a star would actually be something like this, and a triangle will be well, something like this. Okay, so this is what we mean with double bipoles at T and at pi, and those are the formulas to go from triangle to star.